So think about this first. And actually, the C here should be 1. C actually is the power of the carrier. Actually talking about the desired power from that station to that mobile station. Carrier, power of the carrier to this mobile station. This is the desired one. Just one mobile station. All of that because we rearrange it. Not always one. Originally, it should be this one. Power proportional to the distance first power to minus, for example, gamma, and actually this one and this one. Rearrange, cancel this one, and put R to the denominator. So that it should be also like this. So we use the formula power. Follow this one. And actually for C and for I, they are the same form. But they don't have the same distance. For the desired signal strength, it's radius R. And for undesired one, we have a D sub K. And look at this again. First of all, it's R. And for the others, we have D sub K. This is called the path loss model. Well, path loss model, we use the simplified one. Power actually equal to this. Right? So maybe you can take a picture for these, and then we think about these. So that's why I ask you to check this one. Is it okay to reach the formula? Or maybe you can start from that path loss model and apply path loss, simple path loss model to the desired signal strength, and the undesired one actually is the interference. Well, we think about this, and 1 more minute to check. If you have any question, raise your hand. It is called SIR. Of course, you can discuss this for sure. Alright, so let me check one by one. So up now, Veronica, about SR and calculation of SR. It will be okay, right? Alright. And the math about SR and the apply path loss model to reach the final calculation. Any questions? Oh, okay, thank you. And Eugene? Okay for you? Okay, thank you. And Jefferson, Christopher, and Ken. All right. Okay, thank you. So here about the calculation, finally, this is a question from math. E sub K. So what it means actually near the reduced distance, but a bit different from the reduced distance. For example, this one, we have the distance from base station to this mobile station, base station to this mobile station, from different base station to that mobile station.
So the point of mobile station can move in the center as everywhere.
No. Base station it won't move.
Mobile station.
Mobile station will, but this time we consider this one to serve as the worst case. Serving as the worst case. Because we try to have the largest distance here. And so that we will have the smallest power. If we consider the power from this base station to that mobile station.
So
It's worst case.
the corner of, vertex of the hexagon will be the same.
Yeah. Maybe not the same about SIR, but same for this power regarding this one. But maybe sometimes for this current consideration it will be the same because for the other base station maybe we choose one and then that one the distance D should be almost the same. I call almost the same, or maybe found they are the same. Cochannel means reuse because we reuse. Here, for example, channel 1. Channel 1 reused by this cell. So that's why we have cochannel because the same channel being utilized again by the other cell.
The other species.
Yeah, the other base station.
In the real world,
The real world actually we reuse. Reuse. Because of reuse, we will have the same channel. And so they will have a cochannel interference.
we use the same
Actually, you can reuse it at any distance. However, we try to have the same pattern to reuse. So that's why we will have the reuse distance. For example, you can tell the thing, well, perhaps 5, 1, 2, 3 to 5, then you reuse it. But if you don't like it, maybe you can reuse it 7. IV 7 cell, then you reuse it. Or even you don't think we need to follow a pattern. Perhaps we have many closer to reuse it. So we'll cause irregular interference. Here, why we base on the reuse pattern? Because we try to have the suitable reuse distance and try to minimize the cochannel interference. Reuse and also minimize reuse distance. Okay, minimize and so that we can reuse it. So we can have the high efficiency of channel usage. Well, that's it. So this is called cochannel interference to form the SIR. Well, so this is a way to calculate SIR. In the task will perhaps we have some problem and ask you to have the approximate calculation of D sub K. But for me, I may ask you the question to have the exact calculation rather than the approximate calculation. 就我要问你的是没有误差的精准计算，就是请各位用我给你们的那个公式计算公式。Alright, so I will ask you to have the exact calculation rather than the approximate calculation. And also, Matt ever asked me, is it possible to have all possible distance calculation using Cartesian coordinate system? Maybe I'm not sure, but from my viewpoint, sometimes not really easy to have the calculation based on that coordinate system. However, based on the 60-degree coordinate system, we can always find the distance. Alright, so if so, we can try further.